Oh, thank you. It's my third party, and I will cry if I want to. I might actually cry because this talk is all about sort of the perils, the dangers, the absolute minefield that is third-party performance. I'm willing to bet that every website you've ever built uses at least one, if not a handful of third parties, and that's usually out of convenience, right? Because they provide a service that we can't build ourselves because we don't have the funding, maybe not the inclination, the skills. We kind of defer that to third parties. Like I say, mainly out of convenience, but we begin to relinquish control there. We start to shoulder some risk. So over the next 30 minutes, I'm hoping to cover how we can start to measure and identify that risk, and then to start designing around it and mitigating that risk. So yeah, I'm Harry. I'm a consultant performance engineer from Leeds, up north. And I've had a very fortunate career. I've helped many wonderful clients making more scalable, more resilient, and much faster websites. Nearly every client I've ever worked with has had some kind of third-party performance issue, basically a sort of performance degradation problem that wasn't their fault. Now, when I was asked by DeltaV and the steering committee to do a talk on third-party performance, my mind went immediately to this news story from 2008. It's quite old, but the parallels are quite striking. We've got parties, we've got unexpected and uninvited guests, and we've got financial repercussions.
Well, it's the real-life risky business. A teenager holds an alcohol-fueled party for hundreds of kids while his unsuspecting parents are on holiday. 16-year-old Corey Worthington is now facing not only the wrath of mum and dad, but a $20,000 fine from police. I spoke to him a short time ago. Corey, thanks for joining us. The only question that I can think to ask is, what were you thinking?
I wasn't really.
Did your parents say you could have a party?
No.
So
they didn't.
Why did you?
I don't know, it was just a get-together with a couple mates at first, and then we thought we might as well just have a bit of a party, and then it sort of just got out of hand, and yeah.
God, I hate that guy. I hate him so much. But that last little sentence as well kind of got out of hand. One, understatement of the century, but two, again, it made me think of the next thing, which was a lot of the time third-party performance is just things that have got out of hand. I had a client get in touch with me last year. They said, look, we think we've got some third-party performance issues. I was like, look, I've seen it all before. Nothing scares me. Send it over. And this did scare me, because this was a particularly bad one. And I realized the problem was actually a disconnect. What the developer believed they had built that was going to the user was vastly different to what the user was experiencing. This waterfall chart was the website. This is the bit the development team had made. But your dev environment and your prod environment are very different beasts. And your your dev environment is unlikely to have your ad network, all your tracking scripts, all your analytics. So the disconnect was this. This is what the developer had built, but somewhere along the way, a third-party tag manager got involved and invited all its mates. And this is what we sent to the customer. This is an e-commerce site, so it is customers, not users, right? This is striking, and this is largely down to a disconnect. The green is what the dev team believed they were doing. The red is what the customer is receiving. Two things here, right? Most third-party stuff isn't for the benefit of the user. We have to admit that most third-party stuff is for the benefit of the business. So all that red was probably not what the user turned up for, and there's every chance they were paying for it. As of 2015, 18% of Brits actually have a pay-as-you-go phone. So imagine paying for all that red, basically disrespect. So in this talk, we don't really have much time at all, I'm afraid. I could do a full workshop on this, but I've broken it into 4 chunks. Understand what third-party performance is and how it can affect you. How do we audit it, find it, measure it, stress test it? How do we discuss it? How do we feed these findings back to the third-party vendors and internal teams? And finally, how do we mitigate it? What can we do as developers to try and defend ourselves? So understand, how can third parties affect you? And the bad news is, it's in many, many different ways. I'm going to start with the one that I know least about, which is security. But basically, you're inviting potentially unknown people into your house, right? Into your kind of domain. Let's say a third party is slinging across insecure assets, right? Or assets from an insecure origin. You might get mixed content warnings. You might get insecure messages. That's going to start eroding trust. So at the very most basic level, you might start eroding trust with your customers by serving insecure content. But then that insecure content is susceptible to potential man-in-the-middle attacks, someone getting involved in tampering with things, compromise third parties. Then there's also the kind of less considered scenario that maybe the third party is a scumbag anyway, right? What if it's just a nasty third party? January last year, I was flying to Iceland, and I always use the in-flight Wi-Fi, because I still can't quite believe it exists. But my site at this time could either work on a secure or an insecure connection. And what was happening on the insecure connection is that Icelandair were man-in-the-middling me. You see the little logo there? They were advertising to me. An ad blocker had got rid of some of the other stuff, but that was still there. But more concerningly, they were downgrading me to an H1.0 connection. The performance overhead there is quite stark. YouTube were recently busted serving crypto mining ads to users. YouTube was recently caught displaying ads that covertly leech off visitors' CPUs and electricity to generate digital currency on behalf of anonymous attackers. So basically, the third party could just be a scumbag anyway. So my advice here is, at a very, very bare minimum, pull everything from a secure origin, because clue's in the name, right? Who wants an insecure origin? Secure is always best. But then it opens up the possibility to use new technologies, platform features such as H2, Service Worker Broadly, things that we could only get over a secure connection. So security is one kind of risk factor with third parties. Another one would be delays. And it doesn't need me to tell a room full of performance engineers that delays are bad and time is money. But they could present themselves in a number of different ways. Delays on the network, heading to new origins that are previously unvisited. So we've got like DNS, TCP, TLS perhaps. The connection between first and third party origins could be slow. Third party infrastructure. What if the third party is getting DDoSed? What if they're suffering an outage? And again, an often not as much thought about point is, what if the assets they're sending back are badly optimized? What if there's a high runtime cost of a JavaScript library? On this slide, I'm quoting kind of a friend slash client slash kind of peer of mine, Ryan Townsend. I'm quoting him quoting a third-party provider. So Ryan is the CTO of a performance-focused sort of e-commerce startup in Leeds, and he was concerned that one of his third-party providers was slowing him down. So he got on a call with them, and their response was, there's no performance overhead to using our synchronous script. Our typical response time is around 200 milliseconds. First thing is, well, is it zero performance overhead or is it 200 milliseconds, right? Pick one. The second thing is 200 milliseconds is eons when we talk about web performance optimization. Trainline recently discovered that an improvement of just 300 milliseconds would lead to an uptick of £8.1 million a year in customer spend. So proportionately, 200 milliseconds is worth 5.4 mil. Mobify found out that 100 milliseconds was worth $376,000, so 200 milliseconds to them is over $750,000 a year in potential lost revenue. The most eye-watering one is Walmart. They discovered that for every 100 milliseconds performance improvement, that could increase revenue by 1%. So 200 milliseconds, 2% at Walmart scale, that is a potential revenue kind of delta of $230 million a year, right? That's just purely their e-commerce sales, 2%, $230 million a year. That 200 millisecond delay doesn't seem quite so innocent anymore. And finally, kind of the worst case scenario, what if one of these third parties is critical and it's a single point of failure? What happens if them going offline takes you offline also? Sky is another client of mine. Here I'm visiting sky.com and managed to make a secure connection. If you keep an eye on the network waterfall, there's a file here, I think I'm about to find it, that's pending, right? This is a third-party provider, Adobe Tag Manager, currently suffering an outage. What you'll notice is there's no text at all in the tab of the browser, but we have made a secure connection. The reason that we're experiencing this phenomenon is this third-party blocking script on line 9. I'm going to increase the font size a little. This third-party script is a synchronous blocking script that's currently suffering an outage. The parser is not allowed to progress to line 11, so we're not even able to present to the user, this page is responding. A simple optimization here is just swap those two lines around. At least you give some feedback to the user. The real fix is don't have a blocking script on a third party. 100% of the HTML payload has made it over the wire, yet we are showing the user exactly nothing, a blank screen. I should have a separate timer for how long this video is, because I don't know how long to wait before it goes from this to everything. It should be pretty soon. But what's going to happen is Chrome decides that, look, there's obviously an outage on this third party. I'm going to have to time out after a certain amount of time. That certain amount of time is around the corner. Basically, Chrome's built-in timeout is around 80 seconds, 1.3 minutes. Because of one small JavaScript file that was hosted on a third party who was currently suffering an outage, we showed users a blank screen for 1.3 minutes. Add to that this subtle thing of we couldn't even feed back to them in the browser's title tab. 1.3 minutes is enough to assume the site is down completely, and you go and sign up to Virgin Media instead. Potential losses of tens of thousands of pounds over a customer's lifetime. This problem isn't unique to Adobe Tag Manager. This isn't Adobe Tag Manager's fault. If you naively just link to link.rel equals style sheet, href is fonts.google.com, you leave yourself susceptible to the exact same thing. A blocking critical asset on someone else's infrastructure that goes offline is going to do this to you as well. So how do we begin auditing these things? How do we start measuring this stuff and working out what goes on or what the kind of potential cost could be? I'm going to whiz through some kind of things that I do when I audit third-party performance for my clients. The very first thing I do is a very broad sweep of the general overhead and impact of all third parties on the site. I use a really wonderful tool that Tim mentioned yesterday. It was built by our very own Simon, requestmap.webperf.tools. Now, memorize this or take a quick picture of it. We're going to come back to it in a couple of slides' time. But this tool is invaluable for performance, certainly third-party performance testing. I will come back to this. The slides are already live. Don't panic too much. But before we use this tool, we need to do something else. Pick the page you're interested in. I picked CNN. CNN should have the fastest website in the world, right? Because everybody uses them as an example. Run a web page test, whatever settings, whatever location, whatever you need. Grab the web page test ID and plug it into this requestmap.webperf.tools/render/ID. This step's kind of non-mandatory. I just prefer to do it this way around. That's going to give you this wonderful little data viz that my clients and I lovingly nicknamed the jellyfish. And what this is showing us is all the third-party origins that this page has gone to. The size of each blob represents the amount of bytes that origin downloaded. The distance between the blob is the time to first byte. The thickness of the lines between each blob represents the number of requests between them. Now, clients love this. Clients get really into this because it's interactive, it's visual. But as an engineer, I want a little more forensic information, which is great because we can download a CSV, which gives us this treasure trove of information. It tells me the name of the provider, the category of the provider, the origin that provider was using, and other metrics around performance. And what I want to do is take this data and extract every third-party domain. And please don't laugh at me, I don't really write any awk whatsoever, but I cobbled together this one-liner, which will go off and it'll just sweep through this CSV file, and it'll grab us every single third-party domain, which we can then take back to web page test. So we find every third-party domain, run a second web page test against the same page, but this time, in the advanced settings, we can use the block feature, and the block feature will simply prevent any outgoing requests to any of these domains. What I'm basically doing here is doing a before and after. Hey, show me the website as it is now, then show me the website with every single third party missing. This is a very kind of non-scientific finger in the air way of doing things, but it allows me to start discussions with clients. I could tell them that, hey, look, the reason you're suffering bad load times specifically is third parties. You can quite clearly see there that the before and after is quite a stark difference. However, what's kind of nice is start, render, and speed index aren't dramatically different. My hypothesis I'm drawing here is that potentially these third parties are at least included responsibly. They're not blocking very much. But we look at things like number of requests. Requests went up by 4.2 times through the third parties. 4.2 times more assets were requested because of third parties. Page weight, right, bytes in, that increased by 2.7 times. And again, third parties typically aren't user-focused. They're typically, not always, but typically business-focused. There's every chance we've just inflated page weight by nearly 3 times, and someone could be paying for that. However, this is very extreme, very non-scientific. This is basically a case of all third parties, 0 third parties. To drill down a little further, we might want to look at specific third parties. What happens if we've got a slow origin? This is a really great question to ask. What happens if Typekit is slow? What happens if Google Tag Manager is running slowly? What happens if our CDN is running slowly? Really valuable question, and it's quite easy to answer. We're going to turn to a tool called Charles Proxy. I imagine an audience like this, many people will have used it before. If you haven't, go and grab a copy. It's free in the same way that Sublime Text is free. Like, yeah, I'll register that tomorrow. But definitely get hold of a copy of Charles, because you can start to pinpoint specific origins. You can say, leave my entire machine running nice and fast, but slow down the connection between my machine and my CDN, or slow down the connection between my machine and Adobe Tag Manager. This will help people like Ryan work out what that 200 millisecond delay actually might mean. Going a step further, what happens if we have a full outage? What happens if it's not a slow origin? What happens if that third party is down completely? What happens if Bootstrap CDN is down? What happens if Optimizely is down? What happens if they're suffering a complete outage? And again, the tooling exists to make the answer to this question very, very simple. Web Page Test have made available this black hole server. You can just drop this in your host file. This IP address is static, never changes. Drop this in your hosts file and map a domain of interest against it. And this is how you can see what will happen if a third party has an outage. This is how I worked out the Google Fonts problem. Another thing we should look at is missing files. So rather than an outage, which would be kind of a timeout issue, what happens if a file just never makes it across the wire at all? What happens if there's an error in some JavaScript that means your file doesn't execute at all? This is less about performance and way more about resilience, and this is an important thing to kind of factor in. Jake Archibald said 6 years ago now, all of your users are non-JS users whilst they're waiting for your JavaScript to download, and it's absolutely true. A controversial opinion of mine, and you can sort of tell me I'm wrong later, is that we should not optimize for users with JavaScript disabled. Don't optimize for people who have disabled JavaScript on purpose. Instead, consider the fact that, or the scenario that, what happens if that JavaScript fails? Because this could affect a far bigger populace than the disabled JavaScript users, and it's just as impactful. There's a scenario, and again, it was quite a while ago, but it's a fascinating case study to lean on. Back in 2011, in a benevolent kind of way, T-Mobile were trying to help their customers have faster experiences. They were proxying all web content through their own servers and optimizing images that hadn't been optimized, removing comments from files that still had comments in them, minifying files that hadn't been minified. But their comment stripper was pretty naive, and it looked inside jQuery and said, oh, there's a /star here, someone's left a comment in. I'm going to start deleting. Now, that /star wasn't a start of a comment. It was a regex, right? It's a regular expression in a string. And it started deleting, and it just went until it found the closing comment, which didn't exist, right? It just went to the end of the file. For several days, millions of users across tens, if not hundreds of thousands of websites were just crippled, right? Just nothing worked. They managed to completely break the web. Now, this would be solved with HTTPS everywhere, but this is the kind of thing that could happen. What happens to your site if jQuery never made it over the wire? Again, modern tooling makes this quite a trivial one to answer. This is a client of mine who've got a fully client-rendered React application. We wanted to work out what happens if their vendor.js has a critical error. Outage didn't make it over the wire. So in DevTools, find the file you're interested in, right-click, block request URL. Next time you refresh that page, it will not dispatch the request for that file. Turns out we were handling it really badly. If vendor.js didn't make it over the wire, we just showed an infinite loading spinner. We didn't handle this very gracefully at all. Another thing to consider is runtime cost, right? Let's imagine we've managed to get everything over the wire perfectly. It was fast, it was robust, there were no outages, no delays, perfect conditions, but whoever built the third party didn't build it particularly well. There could be a runtime cost. Once again, becoming easier and easier to audit this stuff with modern tooling. We need to run a performance profile in Chrome's DevTools, find this summary panel, nudge over to the bottom-up section of that panel, and simply select group by domain. One of my favorite things as a performance engineer is being able to blame someone else. Now, this is the same client. Sportsbet.io, the world's first legal Bitcoin betting site. I'm keen to stress the word legal there. But yeah, this is a client of mine, fully client-rendered JavaScript application. It stands to reason that the first party is the most expensive domain, right? We are running a fully client-rendered application. I would expect to see us at the top. However, instead of grouping by domain, as you can see here, we're going to group by URL, and something really fascinating happened. For some reason, Google Tag Manager had a higher runtime cost than our 1.4 meg app.js. That's terrifying, right? We've got a definite severe third-party problem here. It's very trivial, very easy for me to pinpoint that problem. What's really, really nice about this view is it actually updates in real time. So as we scrub across our sort of timeline, our sort of performance timeline, these domains will update in real time. Now, what we may have noticed is that SpeedCurve, they're a SpeedCurve customer, you all should be. SpeedCurve had the initial cost because that boots very quickly, but then we had Google Tag Manager and Google Analytics taking the #1 spot ahead of our own code. Google Tag Manager was running before we'd managed to run any of our own stuff. Optimization here is defer all that, right? Don't run your Tag Manager before you run anything else. The next topic is discuss. And this is the most difficult part of the entire process because it involves the hardest thing in computer science, right, which is people. I've been working as a developer for 10 years now, and the technology has always been the easiest thing for a company to solve. The reason discussions around third-party performance is so hard is because you're dealing with people's livelihoods. You can't just rock up to your marketing team and tell them that everything they do day in, day out is ruining the site, even though that may be true. Now, the reason I think it's so difficult as well is we kind of get lazy around these discussions. And every single time I discuss third parties with clients, I get the same response. They're a necessary evil. We have to. We don't want to. We'd rather not, but they're a necessary evil. This is just sheer laziness, right? Because it's nowhere near as black and white as that. We need to dissect what the words necessary and what the word evil actually means. Is this third party necessary? Like, do we actually need it? Because there's a high chance we don't. If we do, then maybe we can have a different discussion around it, like how do we implement it safely? And of course, evil is a very loaded word. I wouldn't consider Typekit evil. A crypto mining ad is icky, right? It's disgusting. I think just brushing things under the carpet with this necessary evil is very counterproductive. So my job as a consultant, a lot of it is having the awkward discussions that teams aren't either equipped or don't want to have. Having discussions with third-party vendors can be quite tricky. It depends on your relationship with them. But if a third party is problematic, you need to form a hypothesis. If you think a third party is slowing you down, you're probably right. But the key thing here is step 2. Gather data. Make sure that you're right. There's nothing more embarrassing than screaming down the phone at a third-party provider, only for them to tell you that you've implemented it wrong. Or this thing here is actually a knock-on effect by something you did. Double, triple check yourself. Make sure you're right? Form your hypothesis, get all the data you can, then let them know. Letting them know can be the hardest bit. There are many ways of going about it. If you've got an account, if you're paying for a third-party provider, there's a good chance you can open a support ticket. If you're spending a particularly large amount of money with that provider, you may even have your own account manager. So it's really easy to get feedback. It's really easy to get in and talk to these providers if that's the case. If it's more of a black box kind of thing and it's just someone you consume but you don't pay them or whatever, there's every chance that they might have a product forum somewhere. They might have something on GitHub. You may be able to open issues and pull requests. But the one that I defer to the most, which is actually surprisingly effective, is just tweet at them. Let them know, hey, look, we're using your third-party script, but it's terrible, right? Or can you give me some advice on this? I've got a little ad in the sidebar of my site, and I wanted them to start using rel equals no opener. I tweeted at them, hey, can you please look into this? And they did, right? A few months, like, took a couple of weeks, but a few weeks later, they implemented it. Done, easy. DHL were running an entire application over an insecure connection. They could run it securely, but they weren't forwarding anyone to the secure version. Tweeted at them, hey, can you just force this onto TLS, HTTPS? Yeah, a few weeks later, done. This is an ad provider that this is like a fourth party. So I was linking to an ad provider who were linking to their own third parties. No idea who Lotame is, but I sent them a tweet. The CTO got back in touch with me saying, hey, yeah, thanks for this. We're tracking it down. It was fixed within hours. I can't promise this will work 100% of the time, and I will admit that having this blue tick does help. But it's better to say something than nothing at all, right? Even just starting with a tweet is better than just saying, well, no, not my fault, not my problem. Even harder still is discussing third-party problems with internal teams. This is where it gets really difficult because you're dealing with colleagues. These colleagues, it's their job to do the thing that you're about to tell them is the wrong thing to do, right? Imagine that discussion. So what I'm going to do is I'm going to show you a tool that I use to actually facilitate these discussions. It's a thing that makes these discussions more objective. Now remember that CSV file we downloaded earlier? That's a full treasure trove of information. I'm going to share a link with you in a second, but I'll talk you through it first. I built a Google spreadsheet. Google Sheets is actually remarkably elegant. I want to learn more Excel and Google Sheets. I built this little thing, this template, where you can import that CSV file into Google Sheets, and it will give you something that looks like this. A list of all the third parties, the domains, the categories. The yellow cells you see here represent duplicates. For example, we've got more than one ad provider, or we've got 10 analytics packages. So anything yellow tells me that these are duplicates. The red shows me that these are bad actors. These are particularly bad offenders. The red is graded from white to solid red, and the 90th percentile is the most solid red possible. So this tells me that, hey, these are the duplicates, and these are the particularly bad ones. Like I say, I'm going to share the URL for this Google Sheet in a second, but when you get hold of it, what you need to do is grab your CSV file that the jellyfish gave you, file, import, go and find the CSV file somewhere on your machine. Here's the important bit. Replace data at selected cell, and just drop your data over this template. And this was the example I showed you earlier. This is the CNN example. Look how many duplicate providers we've got there, duplicate types of platform. Like, there's potentially a lot of waste there, a lot of savings in terms of performance, but probably also cost. If we could decommission even a handful of these tools, we could be saving the business money. Now, I've gone through this with teams before, and the marketing department has been the most excited about this, because they know they've got a third-party problem, but where do they start, right? Where does one start with this? Well, for me and my clients, we start here, and there's a very important column at the end which is currently empty. This notes column is vital. Because what you need to do after you've made this, as a developer, after you've made this spreadsheet, go and have a meeting with your marketing team, but the key thing is ask, don't tell. This very first meeting is all about learning, right? Rock up and don't tell them, this is wrong, this is bad, we need to get rid of this, and we'd like to decommission this. Ask them, quiz them, learn as much as you can. Gather the data, organize a meeting, ask questions. The first step is to learn. This is all about them. This has nothing to do with us at this point. You need to ask them questions like, can you talk me through Google Tag Manager? Can I have a little workshop on Tag Manager so I understand it? And what does this particular third party do for us? Which individual's in charge of this one? The last question is my favorite. Are there any services in here that we don't recognize? It's like, oh yeah, the intern signed that up 2 years ago, and I guess we've never deleted it, right? This is a really insightful question. So the first thing is make this meeting all about them. I don't have time to leave this up any longer, but that's the URL for the spreadsheet. The slides are already live. I'll put them on the last slide. We've got 3 minutes to get through the last section, which is mitigating, right? How do we start to defend against this? First advice, or first bit of advice, is always try and self-host. Self-host whatever you can. Even if it's a third-party asset hosted on a first-party origin, that's better than leaving it on someone else's infrastructure. You've got better control of your own infrastructure. If you've got a third party having an outage but you're running smoothly, that's really frustrating. If you've got an outage, you've got bigger things to worry about than your A/B testing tool, right? Hitting fewer origins means reduced network overhead, less DNS, TCP, TLS. You can dictate your own caching strategy. You can cache more effectively in a more custom manner, more aggressively, stick it in a service worker cache. We can preload our own assets. So where possible, self-host as much as you can, especially critical assets. Where this isn't possible, load everything asynchronously. Don't load any critical assets synchronously because that creates this single point of failure. So with any third-party provider, use their asynchronous loading method. Most third-party providers give an asynchronous loading method. Any third party that doesn't provide an asynchronous loader, that's a red flag. Maybe don't use that third party because they haven't considered the impact of them being a single point of failure for you. It turns out the fix for Sky was as simple as just putting an async attribute here. That's all we needed to do. Now, I can't promise that every fix will be this simple, but basically don't leave anything between you and your customers in somebody else's hands. Second to last thing, I want to give a quick bit of airtime to resource hints. So one of the performance impacts of third parties is visiting these external origins. New origin requires new network negotiation, DNS, TCP, TLS. We might as well deal with this ahead of time. The default behavior is to deal with all this just in time, at a very inopportune moment. Very milliseconds before the file is required, we have to then start negotiating the network. Look at your pages, look at your site, identify the different kind of external providers that you rely on, font providers, social media widgets, ad networks, analytics, whatever third parties you rely on, and pre-connect them. I just drop these into the head of my web pages, and I'm saying, well, these are domains that I frequently hit. They're required on pretty much every page. Got some if statements to make sure I'm not wastefully firing these off. The before shows that all of this network negotiation was happening at the most inopportune point, right, just before the file was needed. The after completely divorces the network negotiation from the file download. Now, the actual amount of time here is enormous, right? So we're looking at hundreds of milliseconds, like up to 500 milliseconds, completely removed from that blocking sort of part of the process. For the sake of a single line of HTML, this could easily get back train lines 300 milliseconds. There might be someone from Trainline in the audience, and I just told them how I did it. They're a client of mine. But yeah, so this is the kind of stuff that we should be looking at. My advice here is only warm up frequent and significant origins, ones that you know you're going to hit very often. The last bit of advice I've got for mitigating third-party problems is the laziest thing I think I've ever done. But the most effective thing you can do is just exercise some restraint. This is the hardest one to quantify, it's the hardest one to achieve, but it's by far the most effective. Just get by with as little as possible for as long as possible. If you don't need a third party, don't use it. If you think you could get by without it, really, really try hard to get by without it. And that's me saying thank you so much for your time. That was a bit of a blast. The slides are already live. If you've got any questions, come and find me. But thank you for listening.